I'd like to welcome everyone here to our NHERI workshop. I will be hosting the majority of this session and I'll be moderating the other two sessions for tomorrow, but I'm also joined by Dr. Karina Bielma. As we go ahead and jump in, I just want to talk about the purpose of this workshop. We hope by the end of this workshop, you will be able to identify NHERI sites, individuals that you can contact at those sites, and also different forms of natural hazards engineering and social science research as well. Develop an outline by the end of today for a collaborative interdisciplinary proposal using the resources that we introduce during this session and using a key question from the NHERI Science Plan that we will introduce as well. So hopefully you will be exposed to a lot of great resources and be able to use them moving forward in a proposal that you write. For our 2-hour schedule, obviously we have our welcome and we'll have our NHERI overview. We'll also introduce all of the sites to you via video, and they will be accessible outside of the workshop on YouTube on NHERI ECO. You may also then have a chance to talk to all of the site faculty or representatives and ask them questions, and we'll talk about how to do that when we get there. We'll introduce the Science Plan 2.0 to you. We will then give you a chance to work on some very specific pieces of a collaborative proposal. And then Karina will introduce successful elements of NSF proposals, and we'll have several NSF awardees come and answer your questions about the proposal writing process and career awards and NSF awards. And then we'll have you reflect on what you've learned and the workshop experience and let you move on with your day. We're so glad that you're here with us. Thank you for all of the site representatives that have joined us and will join us throughout the session and all the time and effort you've put into that. Let's begin with the NHERI overview. NHERI stands for the Natural Hazards Engineering Research Infrastructure, and it's a distributed national facility that enables discoveries that protect human life, reduce damage, and minimize economic losses during natural events. Further, it is a network of 11 different sites. Some of them focus on engineering, some of them focus on social science, through wind, earthquake, tsunami, coastal inundation effects, and they combine research and education and community outreach to prepare communities for natural disasters as well. I want to show you our NHERI network, and these are each sites that offer different resources that can support NSF funded research. And we just want to give you an overview of each of these sites so that you know what's out there. Some of them are more specifically focused on certain areas like wind, but a lot of them you can use several of the sites to be able to conduct research in a more interdisciplinary manner. And you can also work with different researchers across the spectrum to have more interdisciplinary solutions to mitigate natural hazards. I am from the Network Coordination Office, and that is right here at the top. We help kind of bring the whole network together and make sure everyone has what they need. And from the Network Coordination Office, we also have the ECO, which is the Education and Community Outreach. And of course, that's what we're focusing on today. We then have UC Berkeley, the SIM Center, and of course, they focus on computational simulation. And even though SIM Center is centered from UC Berkeley, it is also a distributed center, and there are several people who are part of the network that are throughout the United States at other institutions. We have the University of Texas at Austin, Design Safe, and they focus on community cyber infrastructure. They also have TAC, the Texas Advanced Computing Center, that works hand in hand with Design Safe. We have Lehigh University, and they are part of ATLAS. They used to refer to themselves as large-scale multi-directional hybrid simulation testing, and they still do simulation testing, but they have updated their name. The University of Florida, they focus on wind, experimental wind simulation, and they are out of Gainesville, Florida. But then we have the Florida International University Wall of Wind, And again, they focus on wind simulation. When we move into earthquakes, we focus on UC San Diego. They have the large high performance outdoor shake table. Right now, it is currently going through some remodeling, and I believe it should be open by June. And we're excited for that. UC Davis focuses on geotechnical modeling, and they have the geotechnical centrifuge. The University of Texas at Austin also has a mobile field shaker with various size trucks, including T-Rex, that can go out and simulate earthquake simulations at a site. It doesn't have to happen in Texas at Austin. They can go anywhere in the world. Oregon State University is the Wave Basin and Flume focus with Hinsdale Wave Research Lab, focusing mainly on wave, tsunami, and coastal effects. The University of Washington is the rapid reconnaissance. They have all sorts of wonderful tools that you can take out into the field that will help you conduct your research after a natural hazards event. And of course, this is our newest addition, the University of Colorado Boulder Converge. They focus on social science and the effects that natural hazards have on communities and how we can be resilient. So those are all of our sites. Okay, so we're going to start off with our videos for each of the different sites, and this will give you a better perspective and more in depth than what I could tell you about each of these sites. We're going to start with the Wall of Wind. Dr. Stephen Diaz will be here to answer your questions when we do the breakout session. And again, this is from Florida International University.
The NHERI Wall of Wind at Florida International University is an NSF-funded facility that enables researchers to better understand wind effects on civil infrastructure systems in order to prevent wind hazards from becoming community disasters. The NHERI WOW experimental facility is powered by a combined 12-fan system capable of repeatable testing and up to 157 mile-per-hour wind speeds. One advantage of the facility is the multi-scale and high Reynolds number simulation using 12 fans and a water spray system, which demonstrates the effects of wind and wind-driven rain. The 16,000 square foot fenced-off secure area enables researchers to plan and perform destructive tests for up to Category 5 hurricane wind speeds. Using a wide range of equipment, instrumentation, and experimental simulation protocols, the distinguished group of faculty, staff, and the well-trained team of technical and operations personnel are ready to support your world-class research. The Wall of Wind offers the following testing: high-speed holistic testing with simulated wind speeds, including Category 5 hurricane, destructive tests to study failure modes, wind-driven rain simulation to study water intrusion, full and large-scale aerodynamic aeroelastic testing and atmospheric boundary layer flows, extreme environment testing to develop innovative mitigation devices, and conventional boundary layer wind tunnel testing. If you are interested in learning more about the resources at the NHERI FIU Wall of Wind Experimental Facility and how they can support your research, contact Arindam Chowdhury.
Next, we have the Advanced Technology for the Large Structural Systems Engineering Research Center at Lehigh University. Dr. Liang Cao will be here to answer your questions during our breakout sessions. Next, we have the OH Hinsdale Wave Research Laboratory at Oregon State University. Dr. Dan Cox is here with us, and he is going to answer your questions. If you have any questions about Oregon State University and how they can support your research.
The Hinsdale Wave Research Laboratory was established at Oregon State University in 1972 with the construction of the Large Wave Flume. The lab is the largest nearshore experimental facility in the United States. Researchers from around the world use the facility to examine the effects of wave, wind, and coastal hazards on a variety of structures and coastal areas. The purpose of the research conducted at Hinsdale is to improve the resilience and sustainability of coastal areas, as well as develop innovative solutions to the design of coastal infrastructure. The Large Wave Flume and Directional Wave Basin allow for researchers to explore coastal and nearshore processes, such as nearshore hydrodynamics, tsunami research, coastal structures, sediment suspension and transportation, environmental fluid mechanics, and floating structures. The lab also hosts collaborative projects. One such project, pictured here, is the Wave, Surge, and Tsunami Overland Hazard Loading and Structural Response for Developed Shorelines by Kennedy, Gainham, Barbosa, and Cox. This project created new tools to predict structural damage from inundation events along developed shorelines using computer-based predictive methods. Hinsdale also hosted the NSF Career Award Research from Andrew Myers, which focused on advancing multi-hazard assessment and risk-based design to promote offshore wind energy technology. If you are interested in learning more about the resources at the Wave Research Lab at OSU, contact Hinsdale at oregonstate.edu.
And next we have the SIM Center at the University of California, Berkeley. Dr. Matt Schottler will be here, and he will be able to answer your questions about the SIM Center.
Much of the world's population lives in regions susceptible to earthquakes, hurricanes, or other natural hazards where the risks are compounded by aging buildings and civil infrastructure that often are not designed to resist the hazards. While experiments and field observations are used to understand the impact on communities, computational simulations are an essential component of the science and engineering needed to evaluate and mitigate the potential devastating effects of natural hazards. To advance these capabilities, the NSF-funded Computational Modeling and Simulation Center, or SIM Center, serves the natural hazards community as an essential and central resource that provides next-generation computational modeling and simulation software tools, user support, and educational materials. The SIM Center's goal is to advance the nation's capability to simulate the impact of natural hazards on structures, lifelines, and communities. Headquartered at UC Berkeley, the SIM Center relies on a diverse team located throughout the country with expertise in structural and geotechnical engineering, computational fluid dynamics for wind and water, earthquake and wind engineering, performance-based engineering, social science, state-of-the-art computer science, and software development. The SIM Center addresses these diverse hazards and disciplines by producing flexible and reconfigurable software applications that researchers and practitioners can use to better understand the effects of natural hazards on the built environment. These applications enable the SIM Center to achieve these goals. 1. Provide tools to interface with outputs from the hazards science community. 2. Advance local-scale computational modeling of buildings and infrastructure subjected to natural hazards. 3. Facilitate regional-scale risk simulation with multi-fidelity, high-resolution models and data. 4. Develop tools for integration with social science and urban planning models. And 5. Engage and educate the natural hazards engineering community to advance simulation methodologies and their use. Emerging researchers are trained through workshops, webinars, and programming boot camps. The state of the art in computational simulation is published in a recent report which includes how tools developed by the Sim Center incorporate advanced simulation methods, uncertainty quantification, cutting-edge artificial intelligence techniques, and high-performance computing. The report outlines how the research community can leverage these tools to advance research in various areas of natural hazards engineering. Through its emphasis on multi-hazard and multidisciplinary approaches, the Sim Center benefits the broad natural hazards engineering community. We foresee that policymakers worldwide will be able to rely on researchers' integrated simulations to make vital decisions to mitigate the social and physical damage from natural disasters, thus creating more resilient communities. For more information, visit the Sim Center website and join our community.
Next up is the Center for Geotechnical Modeling at the University of California, Davis. Dr. Ross Bollinger.
The Center for Geotechnical Modeling is located at UC Davis. The center is operated and managed under the direction of Dan Wilson and Ross Boulanger. The research performed at the center is to advance the ability to predict and improve the performance of soil and soil structure systems affected by earthquake, wave, and storm surge loading. This is done by scaling the stress in a model specimen using the radial G-field produced by a centrifuge. The main equipment at the facility consists of a 9-meter centrifuge shown in the lower left, which has the largest shake table in the world, and a 1-meter centrifuge shown in the lower right, which can be used for pilot studies. Both centrifuges are supported by a large and diverse set of equipment that can be used to build models. The facility is spread across 3 separate buildings, moving from left to right. The prep for the 9 and 1-meter centrifuge is done here, as well as housing of the 1-meter centrifuge. Located in the middle building is electronics and sensor calibration, and then finally over here on the right is a 9-meter centrifuge, which is located beneath the ground. For those of you who have not seen how a centrifuge operates, here is a sketch of the 9-meter centrifuge. The centrifuge rotates around this spindle, which is shown here in the center. As you rotate faster and faster, the bucket starts to tilt up, and when you get to 75 Gs, the bucket is near vertical. The G-field produces a normal stress on your model, and an actuator located down here at the base can simulate shaking of the model and any structures that you may have on top of the model. Here's an example of a recent project that used the 9-meter centrifuge. In this experiment, the system-level performance of building foundations founded on MICP improved zones overlying liquefiable sand deposits was investigated. This experiment was designed to understand the effect MICP had on reducing total and differential settlement. The study did show that MICP had an effect at reducing settlements and damage to buildings. Thank you for your attention. For any additional information about the center, please visit our website, which is shown here below.
And now we have the large high-performance outdoor shake table at the University of California, San Diego with Kurush Latvitsada.
Hello, everyone. I am Joel Conte, the PI of the NHERI at UC San Diego Experimental Facility, which consists of a large high-performance outdoor shake table, which was commissioned in 2004. For 15 years, we have used it as a 1 degree of freedom shake table. The table is now under upgrade for 6 degree of freedom capability. It will reopen in October 2021. And with the upgraded shake table, we'll be able to investigate in full 3D and at large or full scale the combined effect of realistic near-field translation and rotational ground motions applied as dynamic excitation to structural, geotechnical, or soil foundation structural systems, including the effect of soil structure interaction, nonlinear soil and structural behavior, and soil liquefaction. You see here some large-scale and full-scale specimens that were tested in the last 15 years. Many building specimens out of reinforced concrete, pre-stressed concrete, timber, metal. You can see utilities. We can also use the shake table in combination with large soil boxes to test geostructures, such as retaining walls here and here. Finally, here we have the NHERI at UC San Diego team, consisting of a number of faculty members with expertise in various aspects of earthquake engineering, with 20 years experience in running this facility. We also have very talented research and development engineers and technicians ready to help you plan, design, and conduct your future experiments. We can be contacted at this general email here, and more information can be obtained on our website at the Design Safe. Thank you very much for your attention.
Next, we have Converge, our newest edition, which focuses on social science. Dr. Lori Peek will be here to answer your questions. She's from the University of Colorado at Boulder.
My name is Lori Peek, and I am the principal investigator for the National Science Foundation-supported Converge facility, which is headquartered at the Natural Hazard Center at the University of Colorado Boulder. Converge was established in 2018 as the first social science-led component of the Natural Hazards Engineering Research Infrastructure, or NHERI. Our team consists of full-time researchers and graduate and undergraduate students here at the university, as well as a global network of partners who are across many disciplines. Converge brings together networks of researchers from geotechnical engineering, the social sciences, structural engineering, nearshore systems, operations and systems engineering, sustainable materials management, and interdisciplinary science and engineering. We support and advance research that is conceptually integrated in an effort to democratize educational opportunities and the research process through a 5-step convergence framework. First, we identify researchers through connecting and collaborating with the 7 NSF-funded extreme events research and reconnaissance networks. Second, we are working to accelerate the education of a diverse next generation of hazards and disaster researchers. To that end, the Converge team has developed a series of training modules that cover a wide range of topics, including, for example, social vulnerability in disasters, disaster mental health, cultural competence, and emotionally challenging research. Third, Converge is dedicated to developing a research agenda for promoting problem-focused and solutions-oriented convergence research in the hazards and disaster field. Fourth, Converge works to connect and coordinate functionally and demographically diverse research teams. Converge has established the first leadership core for extreme events reconnaissance and research that brings together the leaders of the NSF Extreme Events Research Networks and the NHERI facilities that support reconnaissance efforts. Finally, Converge supports and funds convergence-oriented data collection, data sharing, and solutions implementation. We have funded researchers to study the impacts of the COVID-19 pandemic, the recent California wildfires, hurricanes, and other extreme events. These 5 key activities and the many other efforts of the Converge facility are designed to ready researchers to both assess and address the many pressing social, economic, environmental, and technical challenges that lead to disaster losses. For more information about Converge programs, activities, and publications, please visit converge.colorado.edu. Thank you.
Next, we have the Powell Family Structures and Materials Laboratory from the University of Florida. Dr. Brian Phillips will be with us to answer questions about the facility once we have finished the videos.
The University of Florida proudly hosts a shared-use NHERI experimental facility that enables transformative wind hazard research. Our globally unique boundary layer wind tunnel is located within the 20,000 square foot Powell Family Structures and Materials Laboratory. The UF NHERI PIs and staff help guide researchers through the process of vetting project ideas, writing proposals, conducting experiments, and identifying outreach opportunities. The wind tunnel simulates atmospheric flow conditions at a reduced geometric scale. We have developed several features that dramatically increase experimental throughput. The Terraformer is a unique system that controls the height and aspect ratio of more than 1,100 individual roughness elements, providing unprecedented granularity in the control and tuning of approach flow. In less than 90 seconds, the roughness configuration can be changed to alter the boundary layer profile and geometric scale. A suite of instrumentation is available to monitor flow velocity and test subject pressure, base reactions, and motions. Turbulent flow is measured using Cobra probes mounted on a 3 degree of freedom instrumentation gantry that can traverse nearly the entire length, width, and height of the wind tunnel. The gantry is also fitted with a stereoscopic particle image velocimetry system, or PIV. Its energy laser illuminates particles that are dispersed into the flow, while 2 high-speed cameras capture the particle motion to produce 3-dimensional, time-resolved flow field measurements. The simulation of non-neutral and non-stationary flow is achieved by our flow field modulator, or FFM. The FFM slides into the wind tunnel on a track system upwind of the terraformer. This array of over 300 individually controlled fans can produce non-monotonic flow profiles and impart transient gusts characteristic of field-measured extreme wind events, enabling new investigations in wind structure interaction not possible in a traditional boundary layer wind tunnel. Please contact us to initiate your wind hazard research. We're looking forward to hosting your NSF projects in our NHERI experimental facility.
The large-scale mobile shakers is at the University of Texas at Austin. Dr. Tricia Clayton will be here to answer your questions.
The NHERI at UTexas Large Mobile Shaker Facility is located at the University of Texas at Austin. We are home to 5 large mobile shakers and associated instrumentation, including data acquisition systems, geophones, 3-component broadband seismometers, a fiber optic distributed acoustic sensing interrogator, 3-component nodal seismic stations, and cone penetration testing equipment. While our equipment is stored in Austin, Texas, our mobile shakers can be taken anywhere in the world to conduct in situ dynamic testing of civil infrastructure and natural geologic systems. These in situ testing capabilities are essential for evaluating existing infrastructure in actual field conditions that are difficult or impossible to replicate in a laboratory. The NHERI at UTexas Science Plan revolves around 3 main research thrusts. First, non-invasive subsurface imaging from 1D to 3D. Second, in situ liquefaction and nonlinear testing of soils. And third, soil structure foundation interaction and structural health monitoring studies. Some example projects include in situ nonlinear testing of bioremediated soils engineered to reduce liquefaction potential. Here, the T-Rex and Rattler large shakers were paired together to induce higher levels of shear strain deeper in the soil at a site near Portland, Oregon. Here, the triaxial T-Rex shaker was used to non-destructively test a bridge in New Jersey to characterize soil foundation structure interaction under large amplitude shaking. In another project, the shaker from our smallest truck was removed and mounted on a scale building model to simulate dynamic loading on a structure atop a newly developed seismic isolator. For more details on our equipment and videos from past workshops, please visit our website at utexas.designsafe-ci.org.
And also from the University of Texas, we have Dr. Tim Cockrell. He is going to represent the NHERI Cyber Infrastructure and Data Management Team, also referred to as Design Safe, and TAC is also included underneath that at the University of Texas at Austin.
The Design Safe Cyber Infrastructure is part of the NSF-funded Natural Hazard Engineering Research Infrastructure. It provides a web-based platform to enable transformative research that protects human life and reduces damage during natural hazard events, such as earthquakes, windstorms, and floods. As these events become more common and more destructive, Design Safe aims to amplify and link the capabilities of natural hazard researchers in the U.S. and abroad. The Design Safe Data Depot provides private and public disk space to support research collaboration and data publishing through a web interface. The Design Safe Reconnaissance Portal uses a map interface to provide easy access to data collected to investigate the effects of natural hazards. And the Design Safe Workspace provides cloud-based tools for simulation, data analytics, and visualization, as well as access to high-performance computing. There are many examples of how Design Safe data and tools are being used to enhance our understanding of the effects of natural hazards on the built environment. Detailed data and images of damaged buildings have been collected by many groups of researchers after events such as Hurricanes Harvey and Michael. These data have been published on Design Safe and are being used by the broader engineering community to better understand hurricane impact and to use artificial intelligence to better predict potential hurricane damage. To better understand the impact of a magnitude 9 earthquake on the city of Seattle, researchers at the University of Washington and the U.S. Geological Survey used design-safe computing resources to perform regional ground shaking simulations. These simulations incorporate the unique deep sediment structure in Seattle, which affects the characteristics of shaking and can be particularly damaging to tall buildings. The results from these simulations are available via Design Safe and are being used in the design of high-rise buildings in the region. These are just a few examples of how the capabilities of Design Safe are enhancing natural hazards research and becoming an integral part of research discovery. Learn more or join our community at designsafe-ci.org.
Last but certainly not least, the Rapid Response Research Facility, Dr. Joseph Wortman, is supposed to be here to answer your questions from the University of Washington.
The University of Washington in Seattle hosts the NHERI Rapid Natural Hazard Reconnaissance Facility. The mission of the facility is to provide investigators with the equipment, software, and the support services needed to collect, process, and analyze perishable data from natural hazard events. The facility emphasizes three-dimensional, image-based, advanced survey data to serve a range of disciplines. Some of our most requested equipment includes tripod-mounted terrestrial LiDAR systems capable of scanning ranges up to 2.4 kilometers for landscape-scale mapping, as well as smaller and extremely portable systems with a 130-meter range. The unmanned Aerial Phoenix Mini Ranger LiDAR system, customized to meet the needs of the rapid and natural hazard reconnaissance community. 2 Street View camera systems with car and backpack mounts for post-disaster image capture, and a 2-meter-long autonomous survey boat for collecting bathymetric data. In addition to instrumentation, Rapid also provides reconnaissance advisory services and basic logistics support for field investigations. We respond globally to disasters and to field data gathering projects across the world, so we can help you get your equipment where it needs to go. You can find more information about the equipment portfolio, software, and services on our website at rapid.designsafe-ci.org. We are committed to reconnaissance-based science, shared resources, open data, interdisciplinary research, community engagement, and innovation to reduce the adverse impacts of natural hazards. Please don't hesitate to contact us if you have any questions about the facility or about what we can do to help your NSF project.
Does anyone have any questions for any of the sites? How you can use their resources, how you can contact them, specific examples of research that has been conducted at their sites? Did you have a question? Because I can see you now.
I did, yeah.
Go for it.
I was going to type it, and then I thought, well, maybe since no one's talking, I'll go ahead and just ask it.
Yes.
This is for the data depot. In the video, damage information for buildings was mentioned. Is there the capability of having damage information for other types of damage, say to infrastructure, for example? Or like non-structural, I guess, and then what type of building damage? What types of damage information are supported?
Right, so I guess I'll take this one. Tim Cockrell at University of Texas Advanced Computing Center, and also the Design Safe Deputy Project Director. So we really have a fairly open architecture with respect to that. So we don't restrict any file types or any kind of thing. So any data you want to bring to the table is fine. So different research groups, we need to support all the different types of activity going on, whether it's data from experimental facilities or, as you're talking about, reconnaissance data, typically. So We have some applications that support displaying that type of information. We have QGIS available within the interface. So if you brought your files to and your images to Design Safe and you wanted to work with them in QGIS, we have a custom built viewer we call HazMapper, which is another GIS capability that we offer. And as I said, our developers at TAC have developed the HazMapper application. We support LiDAR data with Poetry Viewer and Poetry Converter to get your files into the point cloud. So we have a variety of tools available for you to work on that data that resides there, and to share that data. We have something called My Projects. As was mentioned in the video, we have private and public spaces. So your private space, you can have a project where you decide who gets to share that data with you, and your colleagues, various members of your research team. Later on, when you decide maybe to make a more public availability of that data set, you can publish it through from My Projects, and only select the files out of that you would like to publish, right? And then we have a metadata structure and a file and some recommended guidelines on how to publish that data to make it reusable and discoverable. And Dr. Maria Esteva here at UT is a well-renowned data curation expert, and she worked with all of the partners in the NHERI community to help develop data models for experimental facilities, for field research, for simulations, so that people that have different types of data will have a structure that's amenable to their research community to help find that information. We see a lot of downloads of that data, and also a lot of reuse of that data within our own infrastructure. And we've actually come across some publications that it's always great to find where we didn't even know anyone was using the data, and you find out that they've downloaded from several different projects and done some machine learning projects, right? Because you need large data sets for that. And so, yes, we have a variety of capabilities, and we try and be flexible to allow you to do what you want to do. We are working with a group who is trying to build out, or I'm not trying, but they are currently building out a new tool that we hope to offer later this year, that you could do integrated tagging and damage assessment within our infrastructure with a custom tool for that as well. So look for that later this year.
The other question was, how do you obtain CPU hours at Design Safe with respect to a proposal? And do we request an amount in a proposal?
Very good question. So there's a couple of ways to go about this, right? First off, if you look in the workspace tools and applications, you may find that there are tools there that meet your needs. Everyone in the world can get a Design Safe account. Everyone who has a Design Safe account can use those tools and applications as they are in the workspace. Now, let's say you're doing earthquake research of some kind, and you're wanting to use the OpenSeas application. We do limit the amount of compute power that you can receive through the portal. And this is partly because we have to follow certain federal guidelines on export control and how much compute power people outside the US and various countries could use. Now, if you're at a US research institution, or if you have a collaborator at a US research institution, and you find that we don't have the application you want available through the portal, or you need a lot more resource than we offer through the portal, we have what's called the HPC allocations policy, and it's in our user guides. And the short version of that is you contact us, which is essentially going to get routed to me. And then We can provide you with direct access where you log into one of our supercomputers and do the work you need to do. If you're preparing a proposal and need a letter of collaboration, we do that often. And you know, you tell us what you're trying to accomplish, applications you want, a rough estimate of how much computing time you need, and we can help you understand that as well if you're not real familiar with that concept. We'll work together to help you with your proposal and write a letter of collaboration.
I want to thank all of the representatives that showed up today that were willing to take their time to answer your questions, to be here for their facilities. If you have further questions, you can always go to designsafe-ci.org and you can find all of the NHERI sites and all of the NHERI facilities and their contact and representatives and contact them via email. But thank you so much for joining us. I'm going to give you the chance to step out if you need to. Moving to the next section of our workshop is the Science Plan 2.0. The Science Plan is a report that was created. This is the second version of it, and the second version includes more of the social science aspects, as well as the civil infrastructure and other engineering aspects, but it is an overview of the research which is used to support the grand challenges, as well as the scope and process of conducting multi-hazard research for improving civil infrastructure. You can access the full report on DesignSafe. If you scroll down to the very bottom of the first page, the 5-year science plan is listed, and it will take you to the science plan page where you can download a PDF. But the science plan has been very important in helping guide research at the NHERI sites and to help mitigate natural disaster effects, both in the physical and in the social world. And we want to give you kind of a preview of some of the important parts of the science plan. But before we do that, Karina, I want to ask, do you have anything that you want to share about the purpose of the science plan before we move on?
No, just the report should provide some of the grand challenges and the questions, some major research questions that can help you as you plan your proposal. And this is important because the National Science Foundation especially looks to see some of that in the intellectual merit portion of the proposals. And so this is a document that is created by the community that addresses some of these grand challenges for natural hazards engineering research, that you can also align your projects, align them to these questions and these challenges.
Yes. And speaking of the grand challenges, I do want to introduce you to the grand challenges. I copied these from the science plan so that I could share them with you since we're virtual. Identify and quantify the characteristics of earthquake, windstorm, and associated hazards, including tsunami, storm surge, and waves that damage civil infrastructure and disrupt communities. The second one, evaluate the physical vulnerability of civil infrastructure and the social vulnerability of populations in communities exposed to earthquakes, windstorms, and associated hazards. And the third one is to create the technologies and engineering tools to design, construct, retrofit, and operate a multi-hazard, resilient, and sustainable infrastructure for the nation. So these grand challenges are what I call the what. The what should we be looking at? What are some things that are at the forefront of natural hazards research and will be transformative and making an impact? And that leads us to the 5 key research questions, which I like to call the how. How are we going to create research that is transformative, that addresses those grand challenges, and that is not only influencing our academic community, but obviously we want to impact the society at large. So there are 5 research questions, or I'm sorry, key research questions. 3 of them are on this slide, and there are 2 more on the other slide. We would like you to select one of these research questions to focus on. We can work on beginning an outline of a collaborative proposal based on this question. So the first question is, how do researchers characterize the transient and variable nature of the loading actions imposed on the nation's civil infrastructure from earthquakes, windstorms, and associated hazards? The second question is, how can the scientific community enable robust simulation of the behavior of civil infrastructure to loading from earthquakes, windstorms, tsunamis, and associated coastal hazards, while also considering the effects of these hazards on individuals, households, and communities? The third question, what are the key physical responses, vulnerabilities, and factors influencing post-event recovery of civil infrastructure and communities? And notice that if you have seen the first science plan, the second science plan definitely includes that social science aspect. And the last two questions, what are effective and potentially transformative mitigation actions to achieve community resilience, especially when considering different hazards, shifting vulnerabilities, emerging technologies, and sustainability goals? And then the final key question, how can the scientific community more effectively collect and share data and information to enable and foster ethical, collaborative, and transformative research and outcomes? So we have the key challenges which present the different, I'm going to say, topics that are really relevant and transformative. And then we have the key research questions, which really kind of dig down a little bit deeper and point more specifically to areas that need attention. How else do the grand challenges and key research questions help facilitate research? How have you seen it happen? Karina, I know that we have used the 5 key research questions in the past. Has it been a good jumping off point for researchers to utilize NHERI resources?
So the science plan is usually presented at the Summer Institute for Early Career Faculty, and this is where it is discussed in greater detail. Some of the questions have also been edited due to, the participation from the community to incorporate more of the holistic research agenda. And so researchers are trying to see where their research fits into one of these questions, if not multiple questions. But all of the NHERI research sites can help with with research that addresses any of these 5 questions. So you might have to go about and look for how your research fits into the larger research agenda. And so this science plan is one way to do that. And the 5, once you select a research question, then you can also tailor your research towards in that direction. And in the science plan, there's more narrative about some of the challenges that that we face. Some of it has to do with simulation or having studies that are economically feasible. So this is where the sites come in, and you can talk to the sites about those different opportunities, how they can help to provide some support, letters of collaboration, resources. They also have funding. They can point you to funding opportunities that could help your research make it happen. So yes, these research questions are jumping off points to be a part of the conversation, and you're probably already being a part of the conversation. So aligning it to these questions just makes it again, takes you to that larger picture.
Thank you for that, Karina. I appreciate your contribution. I would like you to select the question that speaks to you most And we're going to use that as a way to begin the collaborative process. We are going to have to reduce the amount of time for the proposal writing because of the extended time at the beginning. So in order to do the collaborative proposal writing, I want to introduce a couple ideas. First of all, you have your question that you've hopefully picked out, but then you need to find the problem or challenge that you can address with that question. And then also something that's also really important with NSF, one of the main parts that they look closely at is the intellectual merit of the proposal. So how will your research advance knowledge inside and outside of the field? They want the whole package. So I want you to go ahead and I'm going to go through all of this, and we'll have one breakout session instead of two, just because of time, and also include the other two important things that NSF will look for: the broader impact. How will your research benefit the community and meet desired societal outcomes? That is really important. And when we get to the NSF panel section, Karina is really well versed in the broader impact. She's an educational specialist who has worked with NHERI for the past 5 years, and she's going to give us a little bit more insight on broader impact. But right now we're just giving you the basics of what it is, and then important details. 4 important details that we'd like you to consider when you are in your breakout rooms and working with the other participants on creating an outline for a proposal. What NHERI sites will help you answer the question or address the problem that you have identified? What technologies can you use to improve mitigation for natural hazards or reduce the effects of the natural hazards? NSF also is always looking for multidisciplinary or interdisciplinary research collaboration in its proposals. So how can you make that a possibility? And then the last component would be inclusion. How can you include a diverse group of individuals, whether it is who you are working with or who is being supported through the research you were doing? But those are all very important aspects of any NSF proposal that is created. And so after introducing all of those, the problem or challenge, the intellectual merit, the broader impact, and the important details, that is what we would like you to focus on in these breakout rooms. Karina and I will be going back and forth through the breakout rooms to see if you have any questions, but you're going to be working with others that are interested in your specific key question to create an outline of the proposal. So elements of successful proposal, NSF proposals. So this is Dr. Karina Vielma. She's an assistant professor at the University of Texas at San Antonio. She's worked with NHERI for 5 years, and she has a tremendous amount of experience focusing on broader impacts, but also with NSF grants and awards.
I want to give this information because it's important. So I'm an assistant professor, and I've had, I want to say, the luck of actually being successful in submitting proposals to NSF. But luck, as my dad says, doesn't just come from doing nothing, right? Like, it takes a lot of work, and it takes a lot of putting in, you know, just the effort into it. So I want to share some things that I've learned, as well as some of the elements that NSF wants to see in the proposals. And we have our NSF program officer who's constantly involved in our workshops. And so some of this information comes from what she has presented as well. And so the National Science Foundation is only one organization that funds, that provides grant funding. And they have some solicitations that are out that are specific to agendas, and, as they call it, that they want to enhance their portfolio with. And so it's very good to know what they're about, as well as what they're looking for. And so they support fundamental science and engineering research, and but not in the medical fields. And so for the medical fields, there's other particular funding opportunities. The National Science Foundation, as I mentioned, they try to ensure that the research is also integrated with education, and this is important because they use public funding to provide these grants, and so it's important to ensure that the public is benefiting from the research that is happening. So they use two major components to review proposals. One is the intellectual merit, and that's the potential to advance knowledge. And the second is broader impacts, and that's the potential to benefit society and contribute to the achievement of specific desired societal outcomes. And if you read carefully on some of the needs that we have in the science and engineering fields, a lot of it is on motivating underrepresented students, women into the fields, also sharing the knowledge of the research, so how people can apply it in their everyday lives, or in their, you know, in the things that they do on a daily basis. So how you can begin is, first you think about what are some of the elements that you are strong in. What are your skills? What's the knowledge that you've gained? Reflect on, you know, what you bring to the table, and again, your expertise in areas that you feel you can contribute to. You can also look at the science plan. You can look at some sample projects. Some of the major things that, and I've done all of these at some point, so you can do your research in specific areas. You can look at the different NSF programs. They have different goals and objectives. And for me, I'm in engineering education, so my research fits into several different areas, but I have to kind of go hunting for those areas and those solicitations out as well. You can sign up for news from the National Science Foundation. There's this link that I can put it in the chat, so that you can sign up and you'll receive, you can choose who you want to receive information from. So, oh, I'm sorry, I'm sending it to someone particular. So there it goes to everyone. You can sign up. I am signed up for everything. So I get news from every single area of the National Science Foundation, and they tell you when new solicitations come out, when there's, you know, specific areas of interest. When with COVID, there were some opportunities for rapid funding to look at COVID issues. So the other thing is that they have specific solicitations that come out. Those you can also look at. They have a due date. There's also some that don't have due dates that you can submit throughout the year, and almost every program has something to that effect. I've also done a search for previous awards in those specific areas, and they have a large search engine where you can do that, and that helps you get an idea of what they're funding, what they're looking at, and you don't want to obviously copy anybody's idea because you want to be innovative and different. But it does help to be able to see what's been awarded. And next is you can also serve as a reviewer, and being on a panel helps you to see also what others look for, and it helps you strengthen your own proposals in the future. There's also the PAPG, which is the document. It's like, it has all the guidelines, and I put it on the chat as well, for your proposal. There's a lot of small details that you cannot miss because the organization, the panelists, they look to make sure that all of these areas are addressed. You can also develop a one-page research project summary, and this will help you to contact people quickly, give them something that's quick that you can say, hey, are you interested in working with me here, or can you look at this? And that one page, we usually use it to contact a program officer, and the program officer will schedule a 30-minute conversation with you, and that one page will be the jumping off point. And they can say, well, maybe it doesn't fit in with this program. Have you tried this other program? And they'll help direct you. The other thing, again, that this PAPG is very important. This is the cover of it. And if you go to that second link that's posted, that last link that's posted on the chat box, it'll point you to this document. These are the important elements of the proposal. There's some that are not that fun. Like, you have to let NSF know what facilities your university has. If you have equipment or other resources, you need to provide that. Also, bio sketches for all of your PIs, co-PIs, and senior personnel. A data management plan, you need to have that. Letters of collaboration are important as well. The bulk of it, I will tell you, my time is usually spent in these 15 pages because this is where we make our case and we provide what we're going to do, why it's important, what impacts they're going to be had in the community with the targeted populations. You also want to see if there's any results from prior NSF support. So if you've been on projects with other people, you can ask them if you can, put your contributions within this report as well. So this is also important. They want to see that, that you've had products from previous NSF support. And if you haven't, it's okay. It's not, the end of the world, because once you get support, then you'll have results from NSF projects. So some tips to help you as you develop your proposal is to start with those research goals and objectives. So I was a teacher for a while. I wanted to join Teach for America, but I didn't because I just went back to my own community and taught for a short while. And this is what teachers start with. They start with objectives. What are the objectives? And sorry, this should be scheduled. What are the objectives for your research? So you start there, what you want to achieve, and then you work to develop a research schedule, a research plan that helps address these objectives and goals. And so that's a good place to start to develop these and make sure that you understand them, that you understand how, what you want to see move forward, right? Like advanced in research knowledge that can be produced through research. And then you want to develop meaningful, broader impacts that connect to your research. This is also important because, again, NSF, because of their goals, they want to see this connection. And you want to take a look at that impact and how it's going to be specifically for your field, for education, and or for community outreach. And I get this question all the time. Does it have to be all three? Can it just be in my research fields? Yes, it can. You just need to specify. You need to let NSF know what that impact on the field is going to be. And then if you don't have any partnerships, or if you don't know how you can connect it, you can always go, and your university has a college of education. There's education specialists that can help you connect to how your research can apply to the community. And you want to recruit others to look at your proposal, edit it, give you feedback, tell you what's going to work, what might not work. And you want to submit the proposal based on the PAPG instructions. You want to make sure that it's aligned to that, and submit early. This is also pretty important. And because we do broader impacts, both Robin and I work on the broadening participation within natural hazards engineering research. We have two programs, the REU program and the Summer Institute. And the goals of these programs are to broaden participation and prepare the future generation of engineers and scientists, and especially amongst underrepresented groups. And so these two programs help us with these objectives. So some tips that I have for you to, as you think about your own research and how you can broaden that participation, is to think of how it ties, how you can tie an activity to what you're doing, right? To help, if your interest is with K-12, then you might want to connect with a teacher, a local teacher that's working in that area, and start building those partnerships. And you want to think about what works for them. Some people say, well, what if I just go into a class and give a lecture about what I'm doing? That's great. However, a teacher has a timeline and objectives, teaching objectives. So you have to work with them to see, well, is that the best method of delivery, a lecture, or can it be a workshop, or can it be an activity for students, or maybe they have a whole month that they could work on something. And so you want to connect with those partners and see what works for them, and then tie it in a creative way to what you're doing. And then you always want to know how you're going to assess your success evaluation, not just of the broader impacts, but of the intellectual merits. And so those are some things to always consider. So in summary, make sure you do your research, that you know your skills, and you know what you want to impact, and reach out to others for support in all phases of the process. This is very important. Your university has resources as well that you can reach out to, and you want to follow instructions. NSF has a lot of very good programs that can be beneficial, but it's so important to follow their instructions and not get kicked out of the running because of something critical was missing. And you want to plan and submit early. That's super important as well. Sometimes I've been on projects that have taken a month to submit, and it's too quick of a turnaround time for most people. But you get feedback afterwards, and they'll tell you, it was denied, but you get feedback saying what areas need to be brought up. I haven't liked being on teams that are quick turnaround, but I am being transparent about that's not a great use of time. So if you have questions, I'm happy to answer them, but I also know that we had some people that were going to be joining us to answer some questions about their own experiences in the grant writing process. And Jennifer's here, Stephanie is here, and who else? I know Matt is still here. I can't hear you, Robin. I'm sorry.
I'm muted, my bad.
Okay.
Ross also volunteered, and Dan also let us know that if he's still here, he's willing to talk about it. So we had a specific lineup that we had, but we have lots of people on the call that have all had experience in NSF proposal writing. Some of them have career awards. Since we have such a small group, you do not have to post it in the chat, but you're welcome to. I want to welcome Dr. Ross Bollinger. He is the PI at the Center for Geotechnical Modeling at the University of California, Davis. He has multiple NSF awards. Also, Jennifer Bridge, who is the PI at the Powell Family Structures and Material Laboratory at the University of Florida. She has an NSF Career Award and multiple NSF awards. And then we have Stephanie Paul. She's an assistant professor at Texas A&M University and head of the Paul Research Group. She is an NSF Career Award winner and an NSF awardee. So I'd like to welcome all three of you. And for anyone else who is here who would like to share their experience, you are more than welcome. We would love to have you. I'm going to open it up to any of the NSF awardees. If you want to share anything about your experience in the NSF, either career award process or just an NSF proposal.
Sure, I can jump in. So thank you for the introduction. So I wanted to just echo some of what Karina said, because she really kind of hit the major points, frankly. One thing I wanted to mention, when it comes to things like broader impacts or data management or facilities, where you can use resources, use them. So, Karina mentioned, within NHERI, there's resources for broader impacts, but your university, I know my university has, don't reinvent the wheel. They've got fantastic programs for reaching out to the community. They've already built those community relationships with the schools or other, outreach activities. And I guess just don't feel like you have to come up with something from scratch. As long as it's meaningful and you can tie it back to your research, definitely use the resources available to you at your university. And along those lines, in addition, if you're going to write a career award or any other type of award, if you're going to work with any of the NHERI facilities, I can speak for our facility, but I think that I can, also speak for the others. We have boilerplate information on our facilities. We can help you with data management plans. In fact, I know all of the sites, if, again, your research may not necessarily be targeted for a NHERI site, but if it is, the sites are fantastic resources. We're successful if we have people writing successful proposals to use our facilities. So we have a lot of incentive to help you with proposal writing. And that, everything from providing the boilerplate information to reviewing your proposal and helping you with, just kind of fleshing out your ideas. So definitely use the resources that are available to you. And I also wanted to echo one more thing that Karina said, which is the more eyes you can get on your proposal, the better. Don't be, I don't know, don't be shy about that, I guess is what I want to say. It's going to go in front of a panel anyways. There's going to be a bunch of people reading it anyways. Just bite the bullet. I know I was nervous about this when I was a new assistant professor. I kind of wanted to hold it tight and get it just right. And I didn't want my colleagues to see it, but all of my successful proposals, it's like there's a, proportional relationship between the number of eyes that see it before it gets to NSF and the success rate. So definitely get people to read it. And if you don't have the support you need at your university, reach out to other mentors or even peers, frankly. Just getting anybody else that can read it is really important. So those are really just echoing what Karina said, but I wanted to emphasize those points.
Thank you so much, Jennifer.
Sure.
Stephanie?
Yeah, I'll jump off of that comment. I was going to say anyways, besides just like sending your proposal once it's kind of formed out to people, you also can start now talking to people about your ideas. It's something that I feel like assistant professors especially are so afraid to do. Like you said, Jennifer, we want to hold everything in. But ultimately that, especially in this NHERI community, networking is really important, and getting that feedback from others who have a lot more experience than you really was helpful for me in the development of my proposal. It also helps to form, your discussion and the way that you're going to communicate that with the program manager. And so that gives you that experience and that practice. So when you have that important conversation, you feel more confident. But I would say the more you talk about your ideas, the more that you kind of are challenged by others who are in the field. Coming to things like this, there are a number of different workshops that go on, especially in the NHERI community, that can be really helpful and giving you an opportunity to say can I use this resource? Okay, if I can't use this resource, why can I not use this resource? Is this something I should leverage or not leverage? All of those things are really important so that you don't just kind of throw everything at a proposal, but instead you're using the aspects that make the most sense for your project. Other than that, yeah, I think that Karina kind of touched on all of the basic, you need to do all of these different things. I think definitely leveraging your institution, whether it be a large R1 institution or another type of institution, both of those things are advantages in NSF. And so leveraging that appropriately is really great. I also didn't go crazy with my broader impacts for my career proposal specifically. I leveraged what was going on at my university as well as what I had already done. And so there can be confidence that you're actually going to be able to do it. So I think especially with the career award, I feel like it's kind of building the panel's confidence in you. So you can do a lot of that before your proposal is in their hands.
I'd like to also just offer, for those that are here, if you would like help in ideas or how you can address broader impacts, both Karina and I, that's what we specialize in. And I'm not going to throw Karina's out there, but you're welcome to contact me and I will be glad to help. And Karina's always very helpful. I know that she's really crazy busy though. She's got a lot of different things going on right now, but reach out to us. We're a resource for that as well.
Yeah, I'm happy to help, especially as Stephanie said, when you start talking about your ideas, then you get better ideas too, or you even get like feedback about those ideas, right? Or connections, collaboration, potential collaborators. And so that's how I've met amazing people, is just talking to them about ideas. So I'm definitely open to talk to you about your ideas and see how you can connect them as well. Each state has different like educational standards or policies or things like that. So that also is important to when you talk about broader impacts and if you want to work with different age populations or things like that. But you can definitely leverage what's within your reach to make it happen, and we're here to help.
Does anyone have any questions for our panelists? You can type it in the chat or you can unmute and ask them. All right, well, I just want to thank Jennifer and Stephanie for coming today and sharing their experience. Is there anything else, any other tips that you want to give before we let you go?
Yeah, I don't know the audience here. So, we talked about career proposals, but I guess, if you're looking at other types of proposals, building the right team is also really important. I guess I would share my pitfall in that regard with kind of collaborative proposals or proposals with multiple PIs. And that is to make sure you have a unified voice. I would say that's been my number one pitfall when I've worked with others. If we don't always, the proposal sounds like it's written by 3 different people. So, I think that's really important to get, just make sure that you and your team, the members of your team are all on the same page and that the tone of the proposal is kind of clean, cohesive, and unified. I was just trying to think of things kind of outside of the career proposal development, but yeah, I think a lot of it's been covered here. So I don't have anything else to add besides that.
Thank you so much.
Yeah, I don't think I have anything specific. I mean, I would obviously be happy to, maybe there's a question in the chat now. I'd be happy to answer any questions.
Okay, yes.
Not knowing exactly who.
Let me pull that up. Okay, so where can I get detailed information about NSF? Is it available for students abroad? I think the last link, Christian, is a great place to look at for proposals. Karina, do you have other suggestions, or Jennifer or Stephanie?
No, I don't know what opportunities are available for non-US students except to become a US graduate student. I'm sorry, I'm not familiar with international programs through NSF that would be appropriate for that.
Karina has put something in the chat that would be a good place for you to start, nsf.gov. So Christian, I hope that answers your question.
Yeah, and we have, for example, we have some partnerships that we're developing with the NCO, NHERI NCO, with international collaborators. And sometimes, so Christian asked this, right, about the international grants. And I also don't know of like specific grants that are for international partners, but I do know that we do work with international collaborators on the grants that we do have. So, it's definitely worth conversations with others who are doing similar work. And again, starting to build those networks for yourself that can get those potential relationships going, so that, a US institution can lead a grant, and then, or a partner, and then, involve some work within your specific area, especially with natural hazards being so international. This is part of what we do within the network.
All right, thank y'all again so much. I appreciate your time, and I learned a lot. And Karina, thank you for sharing those wonderful elements of NSF proposals that are so important.